Okay, I wanted to continue with the last video just a little bit, and I wanted to talk about something pretty simple, and that's slack or surplus, and a little bit more about binding constraints. In this previous example, we determined the optimal solution point was the intersection of our second two constraints. Now, by definition, those constraints are binding constraints, or those constraints prevent us from making more money if this objective function represents profit. So we determined that x1 equals 5 and x2 equals 3 at this optimal solution point. And if you plug those into either of those constraints, you will see that we're using all of that resource. So let's take this first constraint that says 2 times x1, which we now know to be 5, plus 3 times x2, which we now know to be 3, equals, or must be less than or equal to 19. And if you'll look at that, you'll realize we're using every bit of that resource. So maybe we have 19 labor hours, or maybe we have 1,900 pounds of steel, or maybe we have, I don't know, 19 machine hours each week. Whatever that 19 represents, we're using every bit of that resource. We're using 19 units of that resource, and we have 19. So we've pushed that constraint to the limit. That constraint is called a binding constraint. It's actually binding us, preventing us from making more money. And it has 0 slack. So you'll see the difference between the right-hand side and the left-hand side, right-hand and left-hand side, is 0. 19 minus 19 is 0. And therefore it has no slack. We'll see that you see the exact same thing with the other binding constraint, that it will have no slack either, and that's x1, which we now know to be 5 at the optimal solution point, plus x2, which is 3, must be less than or equal to 8. So 8 must be less than or equal to 8. So we're using every bit of that resource. Again, that 8 could be labor hours per day, or it could be a materials constraint. It's something we have limited capacity with. The difference between the right-hand side and the left-hand side is 0, so we have no slack. And that's always true of a binding constraint. It's always true. Now, this first constraint that was x1 must be, let's see, less than or equal to 6, that has a little bit of slack. Okay, this constraint says whatever your value for x1, it's got to be less than 6. Well, our value for x1 wound up being 5. So we have the situation where 5, yes indeed, is less than or equal to 6. So there's a little bit of slack there. There's a little bit of wiggle room. And that slack represents we haven't fully reached our capacity with respect to this particular constraint. So again, maybe 6 is labors, maybe it's some material, maybe it's machine hours. It's something that we haven't fully utilized. And in this instance, we have 1 unit of slack. 6 minus 5 is 1. So that's the concept of slack, if you will. Now, that's oftentimes more important than the solution. We came up with the solution of x1 equals 5 and x2 equals 3, and that's important. But if we want to figure out how do we make more money, how do we get to a better solution, we've got to look at what's constraining us. And it's not the first constraint, it's the second and third. So we might want to ask ourselves, okay, how do I get more of this resource? How do I get more of this resource if I want to make more money? Now, it won't be long before increasing these resources will lead to this first constraint being the binding constraint. And you can visually see that if we increase these constraints, or the right-hand side of these first two constraints, then they essentially move out, just like what you saw with the objective function. So eventually, then the next binding constraint will include this first constraint, which is x1 must be less than or equal to 6. And that should be intuitive. If I get more material and I get more labor, then eventually I'm going to need to get more of this third resource as well. So that's the concept of binding constraints and slack, and more on those topics as we go through some other examples.